G'day guys, got a quick video here today on the fundamental theorem of calculus. In particular, its application to solving derivatives of integrals with respect to functions in the boundaries. Now what we're going to be using today, guys, is we're going to be using some kind of substitution as well as the chain rule to solve this particular problem. So let's just get straight into it. So first of all, what I'm going to do is I'm going to take a substitution. I'm going to substitute u in for 5x squared. So rather than having d dx, I'm going to have d du. So I'm going to say d du of 0 to u, still the same function inside, sine of 2t dt, where u is equal to 5x squared. Now guys, what we're going to do is we're just going to make a little note for ourselves. Du dx is going to be equal to 10x. Okay guys, so from here what we're going to do is we're going to use the chain rule, so I can use this substitution to end up solving the original derivative in terms of x. So what I'm going to do is I'm going to have d dx is going to be equal to d du multiplied by du dx. Okay, from here, so I'm going to substitute in my d du, which is equal to, I'm trying to find the derivative with respect to u of the integral of 0 to u of sine of 2t dt, and then I'm going to be multiplying that by du dx. Now from here, guys, it's quite simple. What I can do is I can apply the fundamental theorem of calculus, so I can say that d dx from a constant to x of f of t dt is just equal to f of x. So from here, what that's going to look like is I'm just going to have sine of 2u here. So from here, let me just get a different color. This is going to be equal to the d du of this is simply going to be sine of 2u times du dx. Now what we can do is we can substitute in what we know. We know that u is equal to 5x squared, so this is going to be sine of 2 times 5x squared, or 10x squared, times du dx, which we figured out as well is 10x. Now this, guys, can be further simplified to make it nice and easy to read to 10x sine of 10x squared. Okay, so let's just do a quick recap. First of all, when I looked at this problem, what I realized is one of the integral boundaries, this 5x squared, is not a linear function like we see in our fundamental theorem of calculus. So what we then had to do, first of all, is just do a substitution to make the 5x squared a linear function. So we subbed in u for 5x squared, so that went in there. Then what we did is, after we do the substitution, we have to use the chain rule because we have to be able to relate the derivative with respect to x to the derivative with respect to the substitution that we've done. What we then did is we used the substitution to easily integrate and then differentiate our function at hand. And then we finished off by making sure that we used the rest of our chain rule, i.e. this du dx on the end here. So finally, guys, once we've done that, we substituted in or back in our 5x squared for u, and then we just simplified it to make it easier to read at the end, and then we were finished. So guys, if this video helped, I know it's only a quick one, but if it did help, give it a thumbs up, subscribe to my channel, I put out new videos all the time, and if you have any problems with this video, please don't hesitate to leave them in the comment section below. I'm always happy to sort of entertain any of your questions that you might have about my explanation. And another thing, guys, if you have any other questions that you'd like me to try and solve, please also don't hesitate to leave them in the comment section below. I'm always looking out for new video ideas. So guys, again, I hope the video helped. You're going to need to keep practicing this so you can recognize all of the different things like this non-linear part of our integral boundary. That's just something that comes with practice. So keep banging your head against the wall. Eventually the wall will fall down. But most of all, guys, just keep on enjoying your maths. I'll see you again soon.